All right, welcome back, infrastructure admins. You are tuning in to the explainer specifically designed to get you past one of the, well, frankly, most technically demanding sections of the Nutanix NCP-MCI 7.5 certification. Today, we're zeroing in on the exact exam objectives. The title of this explainer is NCP-MCI 7.5, 12.8 Volume Groups, Consistency Groups, and Special VMs. We're going to take a deliberate, highly focused teaching approach here. We are completely breaking down the disaster recovery specifications and limitations for these critical components. So grab your notepads and let's get focused.
Okay, let's dive right into our game plan. We'll start with why this matters, walk through VGs and CGs, tackle hardware-tied VM specs, look out for common exam traps, and wrap up with key facts you absolutely must memorize.
Section 1. Why this matters.
So, in the real world, you might just rely on the Prism Central interface to flash a warning when a configuration is unsupported, right? But on the certification exam, rote memorization of features just isn't going to cut it. The test actively goes after the edge cases, those precise limitations, and the really unique operational behaviors of complex DR setups. To navigate those tricky multiple-choice questions with confidence, you literally have to understand the architectural why behind Nutanix limits. Once you grasp that underlying logic, I promise you, the correct answers just become obvious.
Moving on to Section 2, our VGs and CGs walkthrough.
All right, let's kick things off with a consistency group, or CG, and we'll talk about volume groups, or VGs, right alongside it. So what is a CG? It's basically a collection of entities that are treated as a single unit and backed up collectively at an exact recovery point. The why here? It's all about maintaining strict data integrity. Think about an application that spans multiple virtual disks, like a really heavy, demanding database. If all those disks aren't snapshotted in a perfectly consistent state at the exact same millisecond, your database is going to recover completely corrupted. So we use CGs to make sure that the entire application recovers smoothly without any data corruption.
Now let's look at how volume groups and consistency groups interact when it comes to application consistency. This is heavily tested, so pay attention. VGs, by their very nature, do not generate application-consistent recovery points. Because of this, if you try to take a VG and shove it into a CG that's configured for app-consistent snapshots, the system is going to say no way and block you. Furthermore, you cannot generate application-consistent recovery points if the CG has more than one guest VM, or if any VM in the group is associated with a VG. The logic here is super straightforward. If any single piece of that group lacks application consistency support, the entire group loses the capability. It's an all-or-nothing deal.
And this brilliantly illustrates a strict architectural requirement that comes straight out of the official documentation. When you're protecting volume groups with a synchronous replication schedule, it is supported only when both the primary and the recovery clusters are registered to the exact same Prism Central instance. So if an exam question tries to trip you up by asking about synchronous DR for a VG across disparate Prism Central instances, boom, you immediately know it's an unsupported configuration.
All right, Section 3, hardware-tied VM specs.
So let's pose a very common exam scenario to test your instincts. What exactly do you think happens during a disaster recovery failover if the virtual GPU or vGPU models on the primary cluster are completely unidentical to the vGPU models on the recovery cluster? Just take a quick second, mentally predict what the automation is going to do here.
Well, if you guessed that the failover fails entirely, you'd actually be wrong. The VM does fail over successfully, but it does not start. See, because the underlying hardware mapping doesn't match up, the infrastructure admin has to go in and manually update the vGPU configuration to a supported model on that recovery cluster before they can even power it on. For instance, if the VM failed over looking for a Tesla 20, which isn't there, you'd manually update it to, say, an available Tesla 60 model on the recovery cluster, and then you can boot the VM up.
Next up on the hardware front is the Virtual Trusted Platform Module, or vTPM. As you know, this provides secure storage of platform measurements and encryption keys. But there are some incredibly strict DR limits here that you really need to anchor down. First off, you cannot enable vTPM for VMs that are already protected with legacy protection domain-based DR. Second, there's absolutely zero cross-hypervisor disaster recovery, or CHDR, supported. CHDR is, when you fail over from AHV to ESXi or vice versa. Yeah, totally not allowed here. Third, you cannot recover vTPM-enabled VMs to a Nutanix Cloud AZ, though, to be clear, recovering to on-prem and NC2 AZs is perfectly fine.
And finally, if you happen to be running ESXi, both the primary and recovery clusters must be registered to the exact same key management server. No exception.
Okay, let's talk about single root input-output virtualization, better known as SR-IOV. This tech is awesome because it lets a VM interface directly with the physical network card, totally bypassing the hypervisor. But when failing over an SR-IOV VM, here is the exact sequence of events. First, a validation warning pops up. Second, the VM recovers in a powered-off state. And third, the SR-IOV profile is just completely removed. Why does it do this? Well, because those direct physical NIC mappings have to be totally reestablished on the new host hardware. There's zero live migration happening here. That means SR-IOV and Network-Offload VMs force a cold migration during high availability events, which, yeah, can cause up to 7 minutes of downtime.
Moving right along to Section 4, Common Exam Traps.
Okay, here is a classic exam trap that catches a lot of people off guard. It's all about volume group reattachment. For your standard VGs, you absolutely must ensure the Data Services IP, or DSIP, is configured on the recovery cluster. Otherwise, it simply won't reattach successfully. But the real trap? That's with hypervisor-attached VGs. The exam loves to ask if these recover automatically. Let me be clear, they do not. While you can certainly protect and recover hypervisor-attached volume groups, manual intervention is strictly required post-recovery if you want to reattach them.
Here's another really deeply nuanced trap, and this one surrounds third-party backups of vTPM VMs. You've got to differentiate between the type of data being stored. If the vTPM device holds critical data, think Windows BitLocker encryption keys, restoring from a third-party backup might actually render the VM entirely unusable, which means unrecoverable data loss. Ouch. Conversely, if the data is non-critical, like just for Windows Secure Boot, it's an easy fix. The admin or the backup software simply needs to attach a brand new vTPM device during the restore process to get everything up and running again.
All right, let's hit a few rapid-fire edge cases that you need to be able to recognize instantly on test day. First, consistency groups completely lack synchronous replication support. They support asynchronous and near sync only. Mark that down. Second, remember a minute ago when I said VMs with unidentical vGPUs fail over but just don't start? Well, there's a sneaky exception. If you are using synchronous replication, protection of those guest VMs actually fails entirely. And lastly, if you have vGPU console-enabled guest VMs, they do not recover with their special console. They silently just recover with the standard default VGA console instead.
And finally, Section 5, Key Facts to Memorize.
If you remember only one number from this explainer, the crucial point to commit to memory is the number 30. 30 is the absolute maximum number of combined entities you can have in a single consistency group. So whether it's guest VMs, associated volume groups, or a mix of both, combined, they literally cannot exceed 30 within one CG.
All right, let's consolidate this entire lesson into 4 definitive exam anchors. You want these etched in your brain. Number 1, any VM with SR-IOV or network offload profiles will always recover powered off on failover because that physical hardware profile must be reestablished. Number 2, vTPM means absolutely no cross-hypervisor DR and no recovering to the Nutanix Cloud AZ. Number 3, failing over to unidentical vGPUs means the failover itself succeeds, but the VM start is unsupported until you manually update it. And number 4, volume groups inherently have zero application consistent snapshot capabilities.
So I'm going to leave you with this final thought. Nutanix disaster recovery automation is without a doubt incredibly powerful. But any virtual machine that is tied directly to physical hardware, whether that's a GPU, a TPM chip, or a physical NIC, is always going to require meticulous oversight from you, the infrastructure admin. Ask yourself, are your physical hardware mappings completely documented before you attempt to DR failover? Keep that exact mindset as you prep for this exam, and I know you're going to do great. Thanks for learning with me today on this explainer, and best of luck on your certification journey.